Alright team, so just a quick video today. We're looking at 11.4 representing complex numbers geometrically. And what we can do to do this is we can set up an axis like this. We've got imaginary and real as our x, imaginary as our y. And so we can plot things like, let's imagine we wanted to plot 2 plus I. Well, we go across 2, 1, 2 on our real axis, and we go up 1 on our imaginary axis, and so we could plot it like that. So that would be, well, we could just put a dot there, right? So that would be 2 plus I. Now what's really interesting is what happens when we do something like its complex conjugate, 2 minus I. So again we go across 2, but instead we go down 1, and you can see here that we have a reflection. So a complex conjugate is a reflection across the real axis or across the x-axis here. Another interesting thing to note is when we perhaps add 2 complex numbers. So maybe we'll do these ones. So you've got, that's the first one, and maybe I'll do this in red, 1 plus I. That would be this one here. Now if we add them, what happens? Well, we get 3 plus 2i, and if you look at that, 3 plus 2i would be here, and that's essentially adding either this plus that line there, or that plus this line here. You can see this much better in your textbook. Mine's not very accurate, but you kind of get the general idea. I definitely strongly urge you to read that whole page. I think it's page 257. It explains this quite clearly with diagrams. And the same goes if we're doing some subtraction. Okay, so let's maybe say this time we've got 3 plus 2i, and I want to subtract 1 plus 3i. Okay, we're subtracting that. Now, let's just draw this first one in blue. So 3 plus 2i would be there. And then this one we'll do in red, right? 1 plus 3i. 1 plus 3i would be here. But we're subtracting that. So what does this give us overall? It gives us 2 minus I. So we're going to be at 2 minus I. That'll be where we finish. And you can see what's happened here is we are subtracting this here. So this bit here is being subtracted from this. So we go up to here and then down to there. Again, I think you can probably see this a lot better. So overall we're doing this. You can see this a lot better in your textbook. There's a good diagram there. The final thing I just want to briefly show you is what happens when we multiply by I. So let's say we've got 2 plus I, and I can represent that graphically over here. 2 plus I is there. What say I multiply this whole thing by I? I get 2i plus I squared, or another way of saying it is minus 1 plus 2i. Let's plot that. What happens? Minus 1, so we go this way, plus 2i is here. So what has happened? Well, this becomes my y value, and the negative of the coefficient on my I becomes my x value. So they say multiplying a complex number by z, a complex number z by its imaginary number is a geometric equivalent of rotating the point represented by z 90 degrees anti-clockwise about the origin. And you can see that there. If we just pull this over here, we'd get that there. But another way of thinking of it is, take this number, which is on the real axis, it becomes the number on the imaginary axis. Take this number on this coefficient on the imaginary axis and the negative of that on the real axis once you've multiplied by I. So that's a little introduction to exercise 11.4. It's actually really straightforward. Have a go at that, and of course if you are getting stuck, feel free to let me know and I can send you some of my diagrams for this. Good luck, guys.